Hello dear students, welcome to Pen and Paper Chemistry on YouTube. We shall be starting the series of videos on chemical kinetics beginning with lesson 1 today. To start with, let's try reading this sentence slowly and then maybe a little fast. Learning chemistry is easy and fun with pen and paper chemistry. Learning chemistry is easy and fun with pen and paper chemistry. Try to time yourself on this. In how much time are you able to read this sentence first when you're reading it fast and then when you're reading it slow? For me, my speed was, approximately this sentence, I read it in 5 seconds in the first go, and in the second go, I could do it in 4 seconds. How about you? So what we are doing is we are actually measuring our reading speed over here with respect to time. And what is chemical kinetics, right? Chemical kinetics is simply the study of the speed of a chemical process or reaction with respect to time. Now, how do we measure that speed is what we are going to do in this particular. What do you need? A pen and a notebook so that you can take down notes for offline reference. Okay, so let's start with a simple chemical process where hydrogen gas is combining with chlorine gas to give us 2HCl again in gaseous form. What you have to do is we have to write out the rate of this chemical reaction in order to express the speed, the change. And how do we do that? Now, we can either express it in terms of the change in the concentration of hydrogen or change in the concentration of chlorine over a period of time. Or we can also do it in terms of the change in the concentration of HCl over the same period of time. Now, you have to understand over here that the concentration of hydrogen and that of chlorine is reducing because they are disappearing, they are becoming lesser and lesser with time. Whereas the concentration of HCl is increasing, right? So how do we go on to express? So that means we talk about the change in the concentration of hydrogen or change in the concentration of chlorine or change in the concentration of HCl. See, I'm using the word change, and how am I representing it mathematically? By the triangle sign that you see over here. It's the delta sign. Why have we put square, these brackets over here? These brackets specifically denote the concentration. Concentration in what units? We shall be talking about a little later. So we are talking about the change in the concentration of hydrogen, or again delta means change in the concentration of chlorine, so the brackets here, or the change in the concentration of HCl, and how with respect to what? Yes, we are measuring this change with respect to time. So again, what have we put in the denominator? We've got delta T. Again, delta represents change. Delta represents change over here. Delta represents change in this expression, right? So we can either express it in terms of the reduction in the concentration of reactants or increase in the concentration of products. Now, if you notice over here, the concentration of the reactants is reducing, but have we accounted for it in our initial equations that we have mentioned? Because the concentration of HCl is increasing and that of hydrogen and chlorine is decreasing. So what do we do in order to explain that okay, we are taking it with respect to reactants and products, but yes, one is decreasing. So hydrogen is decreasing with respect to time. concentration of chlorine is decreasing with respect to time, whereas that of HCl is increasing with respect to time. So you notice over here, in order to account for the reduction or the decrease in the concentration, we put a negative sign in our expression when we are writing the expression in terms of the reactants. Whereas for the products, we don't do that. Oh, but look at that. What have I put over here? 1 by 2. I've taken half of this. That I had not taken in the initial presentation, right? Initial expression. So how do we account for this? Now again, let's go back to the equation. Now if you notice over here, we've got 1 mole of HCl, right? Because I've not written the coefficient, it means 1. And combining with 1 mole of chlorine, but it is giving you 2 moles of HCl. So what we are saying is, we are writing these two expressions with regards to the change in the concentration of hydrogen or chlorine. We are talking about per unit mole. Whereas here, when I am giving this expression, the next one, when I was taking only this, I am talking about the formation of 2 moles of HCl. That's not right, is it? We should be trying to get them on the level playing field, right? So what do? If for 2 moles, if the formation of 2 moles of HCl can be expressed as this, the formation of 1 mole of HCl would be, yes, so we have simply done the unitary system and we multiply or actually divide by the coefficient that we have got over here. I hope this does make sense to you, right? Okay. What do you have to remember in the expressions that we have written so far? Yes, you have to remember the square brackets that we've got over here, which represent concentration in moles per liter or moles per decimeter cube, depending upon what system of units is being followed. And the symbol delta, the triangle, which indicates change. My question to you is, what do you think is the unit for rate of reaction? Now you know the rate of reaction, you know the unit of concentration, and what are we measuring the change in concentration with respect to? Yes, we are measuring with respect to time. So what is the unit of rate of reaction? Absolutely. Now you notice over here, so let's say my concentration is being measured in moles per decimeter cube. So I'm measuring that change in concentration per unit time. Now that time, actually it can be seconds. I can also express this time in minutes. Yes, so for example, if I'm talking about the reaction of vinegar and sodium carbonate, then my reaction will take place within seconds. As soon as you mix the two of them, there's a brisk effervescence and there we go. On the other hand, let's suppose I'm talking about the dissolution of a salt in, or let's suppose we talk about the reaction of an acid with a base. Then what will happen? The reaction probably takes place in a few minutes. What about, let's say I'm talking about the radioactivity reaction, right? Radioactivity is a process which goes over years, right? So what is the change in the concentration over a number of years, right? So depending upon what reaction you are talking about, you shall put the unit, that particular unit over here, right? So that is why I have put a generalized term. You are not going to write per time. What are you going to write? You're going to either write per second, per minute, per years, depending upon what process is it. Of course, if a reaction is taking place within a few seconds, it's a fast reaction. If it's taking place over a few minutes, it's a slower reaction compared to a reaction taking place in seconds. And what would you say about a reaction which is taking place over years? So for example, a radioactive decay. That is definitely a very slow process, right? Now, as I said, fast and slow are relative terms. You compare these two reactions. Of course, the first one is fast, the second one is slow, right? Now, go on to compare a reaction which is these two reactions. So, a reaction taking place within minutes and a reaction taking place over years. Obviously, boss, you're the one taking place in minutes is faster, whereas the one taking place over years is far more slower. Now you understand why you need this particular topic? Yes, in order to give the rate of a chemical reaction without using superlative terms, terms like fast and slow, without using comparative terms, right? We want to work in terms of numbers. Okay, the task for you now is to write the rate of a reaction given hypothetical reaction. See, I've taken just 2A plus 3B giving me A2 plus B3. Now write the rate of this reaction with respect to the reactants and the products, the rate of disappearance of reactants or the rate of appearance of products. Pause the video, write the reaction, write the expression, and then check it. See, it will help to build your confidence. There you go. Did you get it right? If you did, very good. You must be very, very happy with yourself because you've taken the first step towards learning chemistry in an easy and fun way. Let us now go on to video 2 to take this topic further. Make sure that you keep your pen and paper with you for the next class as well.